Alright, so we'll go over warm-ups in a moment, but first I just wanted you to see the exact formula sheet that you will get on test day. Again, it's got the sums and differences and the halves. The doubles are not there, so you either memorize the doubles or you figure out how to get the doubles from the sums, right? And you get that by saying, well, if both of those are x's, then that's the sine of 2x. So sine x cosine x plus cosine x sine x is 2 sine x cosine x. And cosine of x plus x would be cosine squared x minus sine squared x. So maybe memorize them, maybe use these, maybe sort of both, like have them kind of memorized, but use this to check and make sure you're right. However you want to do it. Again, you will get this exact, some of you will get this exact piece of paper on test day. All right, for warm-up, so if you're just looking on the video, then press pause and give those a try. Remembering that you're not going to get the formula. You will get the formula for sums. You won't get the formula for doubles. All right, press pause now if you're going to do this on your own. All right, number 1. Using a sum or difference identity, find the exact value of cosine 11 pi over 12. So it was good to see almost all of you. You knew how to start this thing, how to break it up into things that add to 12, but also, add to 11, but reduce with 12. So 1 and 10 would not work. 2 and 9 would work. 3 and 8 would work. I saw people use 3 and 8, so I'm going to use 3 and 8. If you use 2 and 9, it's fine. In fact, if you use 2 and 9, you can check and see that we get the same thing here in a minute. I know I saw someone use 3 and 8, so I'll use 3 and 8. Cosine pi over 4 plus cosine 2 pi over 3. And so now I've got unit circle values that add to a not unit circle value. All right, so the cosine sum formula, I'm looking on my formula sheet here, is cosine pi over 4 cosine 2 pi over 3 minus sine pi over 4 sine 2 pi over 3. This is a great test to show your work because we mentioned earlier that I don't feel like there's any major concepts that are difficult. It's just all the little things that could go wrong. And by showing your work, you got a chance to get some partial credit if you mess something up along the way. All right, cosine pi over 4, root 2 over 2. Cosine 2 pi over 3 is negative 1/2. Sine of pi over 4 is root 2 over 2. And sine of 2 pi over 3 is root 3 over 2. I hope you can do them almost that fast anyway to think about those unit circle values. So negative root 2 over 4 minus root 6 over 4. Common denominator happened automatically. And then how do I combine negative root 2 minus root 6? What do I do with that? It's a bit of a trick question. You leave it. Yeah, you can't combine those. So that's as good as it gets. By the way, this is a no calculator test, although a calculator wouldn't do you much good anyway, because if you typed in cosine 11 pi over 12, you're going to get some ugly decimal. But you could use your calculator to check your answer. So if you got answers posted, but negative square root 2 minus square root 6 all over 4. That should be the same thing, and it is, so I know I got that one right. Again, you're not going to have a calculator in your test, but if you're working at home, you can check them with the calculator. All right, tangent 13 pi over 12. So kind of the same process, except that tangents are a pain because you get fractions, sometimes fractions of fractions and square roots, and just a hassle to deal with. Do you remember what we're trying to avoid with tangent?
The denominator being 6.
Yeah, we'd like to avoid a denominator of 6 because that gets us root 3 over 3, and then that complicates the answer. So I would like to avoid 2/12 because that would give me 6. We'll see. All right, to get to 13, 1 and 12 would not work. 2 and 11, that wouldn't work either because 11 wouldn't reduce. 3 and 10. What do we think about 3 and 10? Yeah, it works. Like we get, they're both reduced. They add to 13, but 10/12 is going to reduce to 6. So I'm gonna put a star next to that one. If I can't find anything else, I'll come back and use it. But I'm gonna keep trying. How about 4 and 9? 4/12 is something over 3. 9/12 is something over 4. So let's do 4 and 9. Again, 3 and 10 would work. It would just be harder. So I think it's worth the extra time to figure out how to avoid the over 6, because you'll remove one of the obstacles if you do that. All right, tangent pi over 3 plus 3 pi over 4. Again, looking at my tangent formula up here. Oops, make sure we grab the right tangent formula. Tangent sum formula. So tangent pi over 3 plus tangent 3 pi over 4 over 1 minus tangent pi over 3 times tangent 3 pi over 4. So in the top, the two tangents are added. In the bottom, the two tangents are multiplied and subtracted from the 1. All right, tangent pi over 3 is root 3. Tangent 3 pi over 4. Over 4 is 1, but second quadrant makes it negative. Over 1 minus root 3 times negative 1. So root 3 minus 1 over 1 plus root 3. All right, again, show your work, show your work, show your work, so I can find if you happen to make one of those 100 possible mistakes in there. Multiply by the conjugate. So first, outside, inside, last. And if we've done this right, you've done enough of these maybe to realize that the top doesn't get better. The top kind of gets worse. But the bottom, the square root should go away. So 1 minus 3 in the bottom. So 2 root 3 minus 4 in the top over negative 2 in the bottom. Make sure you divide both things by negative 2. So negative root 3 plus 2. Somehow that got switched around. The answer might look like 2 minus root 3, but those are the same thing. So either way you write that. Again, we'll give you the formula. The rest is just, I don't know, someone should count the steps. 100 is an exaggeration, but 15 might not be. There's just lots of little things going on there. All right, last one, the doubles. You can ignore the ones below that. Okay, so the first two were unit circle problems. This one's a picture problem. So those are the two main. So there's 3 different types of formulas: sum and difference, doubles, and halves. And there's 2 different types of ways to give you information. The technical math or the education term is problem stem. What do I lead you in with? And one lead in is unit circle stuff. The other lead in is draw a picture. So between pi over 2 and pi, that would be second quadrant. Sine is opposite over hypotenuse. And so what's my missing? I almost made one of those 15 mistakes right there. What's my missing side? 5 is sort of right. Not square root of 5. Negative 5. Negative 5, because it's going backwards. So now I've got my picture set up. And even when I grade these, even though the picture isn't like officially part of the answer, on a problem like this, I will assign points to the picture. That way, if you mess up the picture, but then follow your picture through and get right answers, I'll take off 4 points for the picture and then check and see if you got the rest of that right. And so if you miss your picture, you're not going to miss 12 points, you'll miss 4 points or whatever. So draw your picture because you need it, but also that will be part of the answer. All right, sine of 2x. You're supposed to have that one memorized or at least be able to figure it out. 2 sine x cosine x. So 2 sine of x is 12/13. Cosine of x is negative 5/13. Let's see. 2 times 12 is 24. Actually, let's do that a different way. 2 times 5 is 10. Times 12 is 120. And 13 times 13 is 169. Cosine of 2x is cosine squared of x minus sine squared of x. So negative 5/13 squared minus 12/13 squared. So negative 119 over 169. And then anytime we do the tangent double, we will already have given you or asked for sine and cosine of the double. So you don't have to do the tangent double rule. You could just do sine over cosine. And there's at least 3 ways to simplify that from there. You could just know what cancels. You could keep it, change it, flip it, or sort of the middle route is to multiply top and bottom by 169. Then it becomes real clear whose cancels. And we get 120 over 119. Yes, sir.
How do you know if it's going to be like a negative cosine whenever you're making that triangle?
So I knew the triangle had to be in the second quadrant.
Okay, and then your cosine's going to be negative.
So cosine has to be negative in the second quadrant. It's one way to say it. How I knew it was if we go backwards, if we go left, x is going to be negative. And so just be careful with the signs, because there's never any places like we specifically say, hey, watch out for signs, but there's lots of problems where you've got to recognize that, I went backwards or I went down, so x is negative or y is negative. So, if you're watching at home, press pause again and give these a go for you guys in class. So go ahead and press pause and give them a go at home, people. Again, immediately, I know I'm doubling or halving something, so I can throw out those. Which one is it, 28x or 7x? 28. And to me, if you write it out like this, it just becomes real clear that you're doubling from this argument to the argument over here. So yeah, it's 28. But again, the common answer there, or the common wrong answer, is the 7. Why is 1 there? Why would 1 be a bad, or what would make this equal 1? Why is it not 1? Yeah, if that was plus, then it wouldn't matter what the argument was. Cosine squared plus sine squared would be 1. So that's why that's there. People forget which way that formula works. Number 5, cosine is 4/5, and x is in quadrant 4. Quadrant 4, cosine is adjacent over hypotenuse, 4 over 5. What's my missing side here? -3. So again with the negatives, just be careful. Alright, the sine formula is plus or minus square root 1 minus cosine x all over 2. which means if we messed up the 3 and negative 3, it wouldn't matter. So that's nice. 1 minus 4/5 all over 2. Okay, so one like that. There's other people in other classes who are definitely saying, I don't need to do your way, Mr. Wolf. I can just do 1 minus 4/5 and divide that by 2. And if you can do that, that's fine. Like 1 minus 4/5 is 1/5. 1/5 times a half is 1/10. We're good. But I'll work it like I work all the others, just in case. I'm going to clear the denominators. And so that gets me 5 minus 4 over 10. So yeah, sure enough, square root of 1/10, which is root 10 over 10. But I've still got this plus or minus. How do I know which one to pick? I mean, I pick it based on quadrant, but on the quadrant of x or the quadrant of x over 2, like which quadrant what angle am I talking about? Remember the trick here? If x is in quadrant 2, x is in quadrant 4, so x over 2 is in quadrant Roman numeral 4 divided by 2. That looks funny, but it's 2. So in quadrant 2, sine would be positive. And what am I going to do the cosine one? But it would be negative, because in quadrant 2, cosine is negative. Questions on those?